We need to do some college algebra, so pretend that this is like an online class for the moment. And we're going to talk about graphs of rational functions. Rational functions are two polynomials that are being divided. So one thing you're going to need to remember for today is the degree of a polynomial. So if you look through all of your terms in your polynomial and find the one with the highest exponent on your variable, that is going to be the degree of your entire polynomial. So this is a degree 6 polynomial. When you graph rational functions, they can have something called asymptotes that your polynomial graphs did not. They're essentially lines that your graph gets closer and closer and closer to. So for example, let me sketch you a little picture here. Maybe I've got this rational function and it's getting closer and closer and closer to this vertical line, but it doesn't actually cross it. Vertical asymptotes never actually get crossed. Maybe that's the line x equals 2. Then that's a function that has a vertical asymptote. Where they kind of come from, we'll talk more later, but they're essentially, if you have any x values that make your function undefined, so make your denominator like equal to 0, you can't divide by 0, which means you're going to have a vertical asymptote at that x value. So, for example, if that was my equation, that would be one that would have a vertical asymptote of x equals 2, because if I try and plug 2 in the denominator, my function's undefined there. Other kinds of asymptotes, you can, instead of approaching a vertical line, your function could approach a horizontal line. So, same idea. They tend to be lines that get approached as your x values get like bigger and bigger and bigger, so maybe it kind of flattens out. And it gets closer and closer and closer in the long run to some horizontal line. So as you go towards the right there, it kind of looks like it's trending towards the line, if that's maybe the horizontal line of y equals 2. That would be a horizontal asymptote of y equals 2, and your graph can cross them. Mine clearly does. Slant, or they're sometimes called oblique asymptotes, are kind of the same sort of idea. They're slanted lines, like y equals x or something, that your function's graph gets closer and closer to. So maybe it's kind of sandwiched in between there. So I could have some slant asymptotes. All right, let's take a look at a graph and kind of identify your asymptotes based on your graph and your equation here. So I always look at my vertical asymptotes first. So if you look at your graph here, it looks like it's getting kind of closer and closer and closer to the vertical line of x equals 1. So I'm going to say based on that graph, you're going to have a vertical asymptote of x equals 1. And you could also look at your equation. If you try plugging 1 into your denominator there, that would make your denominator equal to 0. So x equals 1 is going to be your equation of your vertical asymptote. All right, horizontal asymptote. It looks like it's getting closer and closer and closer as you go towards the right with bigger and bigger x values, or the left with smaller and smaller x values, getting closer and closer and closer to the line y equals 1. So I have a horizontal asymptote of y equals 1. What if you don't have a graph? What if you just have an equation to look at instead? Let's talk about how you determine the equations of your asymptotes. So, like we already kind of talked about, vertical asymptotes happen anywhere that you have your denominator be equal to 0. So if you have some x value that's not part of your domain, if it makes you divide by 0, you're going to have a vertical asymptote there. So for example, say that's my equation. Figure out what makes your denominator equal to 0. You could factor it, or you could just set it equal to 0 and solve it. This one would actually have two vertical asymptotes at x equals 2 and negative 2. Horizontal and slant asymptotes, basically you could have one of three cases occur, and it has to do with your degree of your polynomials that are being divided in your rational function. So the first case is you might have a rational function where the degree of the numerator is less than the degree of the denominator. In that case, you just automatically get y equals 0 as your horizontal asymptote. So example of one that would meet that requirement is, let's say this function right here. The degree of the polynomial on top is 2. The degree of the polynomial on bottom is 3. Since the degree of the numerator is smaller than the denominator, your asymptote is going to be a horizontal line of y equals 0. Well, the degree on top doesn't have to be smaller than the degree on bottom. You could instead have a polynomial or a rational function, where the degree of your two polynomials being divided are equal. So I just copy and paste it. Let's change it up. If I switch that to x to the third on top, then those are both degree 3 polynomials. You're still going to have a horizontal asymptote in that case, but it won't be y equals 0. It'll be what you get when you divide the leading coefficients on those two highest degree terms. So your degree 3 terms right there, if you look at their coefficients of 1 and 3, if you divide them, that's the equation of your horizontal asymptote. So y equals 1/3 would be a horizontal asymptote of that function. The last case that gives you any asymptotes is the one that gives you a slant asymptote. So this is, if you compare your degrees, if the degree of the numerator is exactly 1 more than the degree of the denominator, that is what gives you a slant asymptote. So let's copy and paste, change things here. Let's just make it actually that right there. So top's degree 2, bottom's degree 1. That's exactly 1 larger on top than on bottom. That's the only case that's going to give you a slant asymptote. To figure out its equation, it's actually a little bit more work. You have to actually do your division. So if I divide those two polynomials, you do long division in this case, because synthetic division doesn't work for 3x. So if I run through some long division here and divide those two, I'm going to end up with 1/3 x plus 2/3. It actually ends up dividing in evenly, but even if it didn't, you do your division. If you have a remainder, just disregard it, ignore it. Your equation of your slant asymptote is just what you got when you divided for your quotient without any remainder that you might have had. So that would be that slant asymptote. All right, so let's find all the asymptotes of these rational functions. I'm going to start with the vertical. So to find your vertical, remember, if you set your denominator equal to 0, and determine any values for x that make it undefined. In this case, I could factor out an x. I end up with 2 vertical asymptotes, one of x equals 0 and one of x equals 5. To determine any horizontal or slant asymptotes, I need my degrees. So constant's degree 0, bottom, that's degree 2. Well, if you look at your 3 cases, we're in case 1. Degree on top was smaller than the degree on bottom. That automatically is going to imply that our horizontal asymptote is y equals 0. On B, again, I would start with the vertical. If I take and set my denominator equal to 0, this is actually one where you're not going to have any vertical asymptotes because our equations of our asymptotes need to just be real numbers, not imaginary numbers. So there are no vertical asymptotes because there are no real numbers that make my denominator equal to 0, that make my function undefined. Comparing degrees, top's degree 2, bottom's degree 2. That means we're looking at the case where my degrees are equal to one another. So I'm going to divide my leading coefficients, which are just, that's a 1x squared and a 1x squared. So my coefficients on my highest degree terms are just 1 and 1. So my equation of my horizontal asymptote will just be y equals 1 over 1, which is just y equals 1. All right, you can probably just go straight to your equation of your vertical asymptote being x equals 4 here from your denominator. Oh, everybody's least favorite case, degree 2 on top, degree 1 on bottom. Hey, the top's 1 larger than the bottom. That means we have our slant asymptote, which will take us a little bit more work to find the equation of. We're lucky on this one though, because we can do synthetic division instead of having to do long division. So let's do some synthetic division. Oops, don't eat my x. Don't forget to put in your 0. So if I run through my division here, 2, 8, 35, I end up with 2x plus 8, and then a remainder of 35. But the remainder doesn't matter for my equation of my asymptote. My slant asymptote is just y equals 2x plus 8. So no horizontal asymptote on that one, just a slant asymptote. All right, last one. I want to point out that you should always simplify your rational function first if you can, because it affects what asymptotes you really have here. I can factor the top and then divide out my factor of x minus 5, so my simplified function is just y equals x plus 5. I don't have any vertical asymptotes in that case because although 5 made the original function equal to 0, it doesn't make my new simplified function equal to 0. What it would look like if I graphed it is I'd actually have like a little hole in my graph at x equals 5, but no asymptote, because I was able to divide out that problem factor of x minus 5. So I don't have any vertical asymptotes. You also, since you simplified it, if you look at it, it's not a rational function anymore. There are no horizontal asymptotes, and there are no slant asymptotes. So look at your simplified version of your equation to figure out your asymptotes. No asymptotes. And revisiting x and y-intercepts one more time here. Same old, no matter what kind of function. If you want the x-intercept, figure out what makes your y-coordinate equal to 0. You don't have to have an x-intercept. This one, 0 doesn't equal 3, is not going to ever cross the x-axis, so it won't have any x-intercepts. Switch it up for your y-intercept. If I'm on the y-axis, I know my x-coordinate of that point would be 0. Plug 0 in for x. You end up with negative 3/5. So this function will cross the y-axis at 0, negative 3/5. All right, that's kind of your intro to rational functions.